Hello everyone, a very good afternoon to all of you. My name is Prakhar Shrivastava and I am presenting you this particular course on manufacturing crash course, and today we are going to start with the forming of metal forming introduction part. Although the two lectures in sim is already we are running two lectures behind, so I will be covering it by tomorrow or day after tomorrow. I'll take a gap, or most probably I will be covering it in the extra classes. But since I cannot I have to complete this by 5th of January, so that is why I cannot compromise with the schedule. That's why I started with the introduction of forming, which was pre-decided, and we'll be continuing. You don't worry, we'll be continuing and we'll complete the introduction of this not introduction, the computer integrated manufacturing, specifically the motor wala part. It is very important, very important. Okay, so I think that we are good to go with the lecture. Please message in all the groups about this particular course. You can share the link so that other people can join. This is the first lecture on metal forming, and those who have not studied metal forming, you can cover 80% of the forming from here only, because this is a crash course. I cannot take it in very detail, but yes, I will be covering 80-90% of the syllabus in the shortest possible time. ज़्यादा time आपका waste नहीं होगा, बहुत ज़्यादा time हम dedicate नहीं करेंगे किसी भी एक topic पे, but yes, covering of the topic so that you can solve at least the previous year question. That would be my approach. That would be my approach. So let us start with the video. Hello everyone, my name is Prakhar Shrivastava. I have secured All India third rank in GATE 2016. Then I took admission into IIT Bombay and finally completed my masters from NITI Mumbai. From past 3 years, I am teaching on an academy with an experience of teaching approximately 22,000 plus followers. So thank you all for your love and support. The subjects that I deal with is industrial engineering, manufacturing technology, and engineering mathematics. Industrial engineering, manufacturing technology, and engineering mathematics are the subjects that I deal with. So let us move forward about the plus and the iconic subscription. The plus and the iconic subscription are nothing but the paid courses that are launched by Unacademy, where you would be provided with the live classes to get the knowledge. You would be provided with the crash course to revise what you have studied in live class. Then you would be provided with the rank improvement batch. You would be provided with the rank improvement batch to practice questions that you have studied in the live classes. And fourth, once you have studied, you have revised, you have practiced, then you can give the weekly test to monitor your growth and monitor your you can say position as far as your competitors are concerned. If you are having any doubt, you can ask in every third lecture. You would be getting an opportunity to ask your doubt. And finally, you would be getting English in Hindi. You would be getting the complete content in English and Hindi both. ठीक है, चलो. Now very important. What are the benefits of iconic subscription? First and foremost, the most important part is this, that you will get all the benefits of plus subscription. Along with that, you would be getting a personal coach to guide you throughout your association with Unacademy. You would be getting a study plan, what to study, when to study, how to study, from where to study. ठीक है, preparatory study material will be given, that is practice set will be given, the theory section will be given, so that you don't have to face any issue. Then booster session will be given. Booster session will be conducted to keep your motivational level high throughout your preparation. And my personal favorite, personalized test analysis will be given. Personalized test analysis will be given. Personalized test analysis will be given so that you can analyze your mistake. You can identify your weak areas, your gray areas, your strong areas, and accordingly align your preparation. But for that, you should know what your analysis is. So that is why my personal favorite, personalized test analysis. What are the charges for this? It is 27,225 rupees for 1 year, 34,650 rupees for 2 years, 1.5 years, and 39,600 rupees for 24 months, or you can say 2 years. Okay. So these are the charges, but these are the discounted prices that you will be getting after applying the code crack10. After applying the code crack10, which code you need to apply? This is the code that you need to apply. This is the code that you need to apply. Is it clear to all of you? This is an important code that you need to apply. Chalo. Now, what are the charges for iconic subscription? It is 45,225 rupees for 1 year and 66,600 rupees for 2 years. That's it. No 1.5 year plan is available for iconic subscription. 45,225 rupees for 1 year, 66,600 rupees for 2 year. When? Only and only when you apply the code. Which code you need to apply? Prakhar 21. Which code you need to apply? Prakhar 21. Which code you need to apply? Prakhar 21. Is it clear? Chalo. And apart from that, very important announcement that from 28th of December, mechanical engineering batch A is being launched. Batch A is being launched, where the syllabus will be completed in detail, and it is going to start from 28th of December. 28th of December. And there is one more person in this, DS Negi sir. He will also be there. He will also be there. समझ में आया? चलो आगे बढ़ते हैं. Unacademy Combat was there on 16th. But I have kept this slide just to remind you that you should continue your preparation, because the next combat is going to be happen very soon. Very soon the dates will be announced, and I want a lot of you to actually participate in it and get some really exciting prizes. What are the prizes? You can clearly see from here. These are the prizes. Apple MacBook Air is the first prize. Apple iPad Mini is the second prize. Apple AirPods is the third prize. And yes, top 100 rankers will also be getting rupees 1,000 worth Amazon vouchers. Rupees 1,000 worth Amazon vouchers. Is it clear? Chalo. Rupees 1,000 worth Amazon vouchers. Is it clear? Chalo. अब तो ये वैलिड नहीं है. ये स्लाइड्स मैंने इसलिए रखी हैं. आई हैव केप्ट these slides just to remind you that there are certain competitions that Unacademy is hosting. The first part of that gate combat is already over. The next part is going to come very soon. So just get ready with that part. Just be ready with those parts. ठीक है? चलो आगे बढ़ते हैं. So today we have to start with metal forming. Metal forming. Now metal forming is nothing but you make these products using casting. You make standard products using casting, and then you apply force and pressure you apply force and pressure to change its shape. To change its shape. To change its shape. ठीक है. Apply force and pressure to change its shape. ठीक है. Now, what you need to learn? I'll give you the mind map of metal forming, that what is metal forming, what we are going to study in metal forming, everything will be clear. But just try to understand. Metal forming में कुछ नहीं होता. You are having a box and you apply the force to change its shape. You apply the force to change its shape. You apply the force and pressure to change its shape. Is it clear to all of you? Is this thing clear to all of you? तो अब आपको ये चीज समझनी पड़ेगी थोड़ी सी, that in metal forming you have to learn what is the amount of force and pressure that you need to apply. What is the amount of force and pressure that you need to apply? That you need to apply. Second, what are the different dimensions of the workpieces pre and post processing? What are dimensions? Dimension calculation is very important. Dimensional calculation is very important. What are dimension? What are dimensions pre and post processing? Pre and post processing. Pre and post processing. These are some of the important part. But कैसे लगाओगे? How will you apply force and pressure? There are multiple ways in which you can apply force and pressure. ठीक है, रोलिंग से कर सकते हो, फोर्जिंग से कर सकते हो, एक्सट्रूशन से कर सकते हो. तो you are having multiple ways in which you can apply force and pressure. You are having multiple ways in which you can apply force and pressure. ठीक है. Now, what are the different ways that you need to study under metal forming? How will you apply metal force and pressure in metal forming? Then you need to apply. There is light deformation and there is heavy deformation. अब देखो, if the sheet is thin, obviously don't you think you have to apply less load? Otherwise the sheet will crack. If the thickness of the sheet is less, the capability is less, obviously you need to apply lower forces. So light deformation is usually used for sheet metal operations. Sheet metal operations, and this is used for bulk deformation. This is used for bulk deformation. Now, what are the processes that comes under sheet metal operation? The first one is the punching. That is punching out a hole. Suppose you are having a sheet. You draw you try to cut a circular part from between. Yes or no? So now after this part is removed, the remaining sheet is known as punching operation. ठीक है? So punching. Now punching is done on thin sheet only. It cannot be done on thick sheet. Punching, blanking, deep drawing, bending, and other operation. Other operation के अंदर small operations आएंगे like notching, ठीक है, lancing, nibbling, ठीक है, etc. All these comes under light deformation. All these comes under light deformation. And when it comes to heavy deformation, the importance are rolling. Rolling operation is a heavy deformation. Then extrusion is a heavy deformation. Then wire drawing is a heavy deformation. Wire drawing is a heavy deformation, and apart from that, forging is also a heavy deformation. Is it clear? So these are the different methods with the help of which we can apply force and pressure to change the shape. We can apply force and pressure to change the shape. We can apply force and pressure to change the shape. These are the methods. I am giving you 1 minute. Please note it down. यही आपका metal forming का syllabus है. And there are some important topics like metal forming defects, which is actually very important. बस यही है. लेफ्ट हैंड साइड पे आप देखोगे तो यहाँ बहुत सारी चीजें आ जाएंगी. कॉइनिंग, एम्बोजिंग, एटसेट्रा. बहुत सारी प्रोसेसेस होंगी. ऑल दीज प्रोसेसेस बिलोंग टू द लाइट डिफॉर्मेशन. All these processes belong to light deformation. I'm giving you 1 minute. Properly note it down. Apart from that, we have to discuss about the defects, hot and cold working. Simple चीजें हैं ये. Hot and cold working, defects, hot and cold working, basics of material, basics of material. ठीक है. These are some of the important topics that are left, that are not covered, or this is your syllabus for metal forming. This is your syllabus for metal forming. This is your syllabus for metal forming, and we will start with punching and blanking. ठीक है. We will start with punching and blanking. You don't worry about that. Basics of material, that is like stress strain curve, everything will be covered. You don't worry, but we will start with punching and blanking. I'm telling you, I'm giving you a minute of time. Please note it down. I'm giving you a minute of time. Please note it down. जल्दी करो. एक बार ये हो जाएगा, then we will start with punching. Just a second, I'll drink some water and I'll come back. Okay, so now we are good to go with the punching part. To give the heading punching, blanking and punching. Blanking and punching. देखो, if this is a sheet, I place the sheet under a punch and a circular part is removed. Now you have divided this entire thing into two parts. One is this removed part and one is the sheet with a hole. One is a sheet with a hole. One is a sheet with the hole. One is a sheet with the hole. One is a sheet with the hole. Now, if this part is useful, we call it as blanking process. And if this part is useful, then it is known as what? Punching operation. Then it is known as punching operation. Then it is known as punching operation. Then it is known as punching operation. Is it clear to all of you? ठीक है. So अब अगर मुझे एक शीट में होल्स की जरूरत है, then I will call it as punching operation. And if the removed part is useful, then I'll call it a blanking operation. Sir, both the operations are same. Sir, both the operations are same. Sir, both the operations are same. Then why we are calling them different? You will come to know about this. Don't worry, you will come to know about this very shortly. You will come to know about this very shortly. Okay, but you need to understand this, what the difference between punching and blanking. The difference between punching and blanking. So let me just pick up my book and I'll start. Punching and blanking is very important topic. तो लिखो प्रेस. गिव द हेडिंग प्रेस ऑपरेशंस. गिव द हेडिंग प्रेस ऑपरेशंस. प्रेस ऑपरेशंस. प्रेस ऑपरेशंस. गिव द हेडिंग प्रेस ऑपरेशंस. और उसके बाद लिखना चालू करो. एक एक करके प्रॉपरली डिटेल्ड नोट्स बनाओ. इट विल हेल्प यू टू रिवाइज बेटर. प्रेस ऑपरेशंस. देखो देखो, इन कटिंग ऑपरेशन the workpiece is stressed beyond its ultimate strength. In cutting operation, the workpiece is stressed beyond its ultimate strength. Beyond its ultimate strength. अल्टीमेट स्ट्रेंथ से ज्यादा जाता है. ठीक है, अगर कटिंग ऑपरेशन है तो अल्टीमेट स्ट्रेंथ से ज्यादा लेके जाना है. ठीक है. Whereas in forming operations, whereas in forming operations, whereas in forming operation, the stresses are below ultimate strength of the material. The stresses are below ultimate strength of the material. Ultimate strength of the material. The stresses are between, और ऐसा लिखो, or in better words, or in better words, or in better words, or in better words, the stress is between, the stress is in between, the stress is in between yield strength and ultimate tensile strength. ये कौन सा जोन होगा? ये प्लास्टिक जोन होगा. If you have to deform a material permanently, obviously you have to go into the plastic zone. Yes or no? So that is why ये आप basics में समझ जाएंगे that everything is performed in plastic zone. So plastic zone is beyond yield point but less than ultimate tensile strength. तो उसी के बीच में हमें स्ट्रेस लगाने हैं to deform a material. लिखो. Give the heading blanking. Now give the heading blanking. Give the first heading blanking. Give the first heading blanking. Give the first heading blanking. Blanking लिखो क्या होता है? सब कुछ कवर अप करेंगे. We will cover up everything. You just check. You just literally chill. लिखो. It is an operation. It is an operation of cutting. It is an operation of cutting a flat shape from the sheet metal. A flat shape from the sheet metal. A flat shape from the sheet metal. From the sheet metal. From the sheet metal. The article punched out. The article punched out is known as blank. The article punched out is known as blank. The article punched out is known as blank. And if blank is important for our process, देखो कई बार क्या होता है, the removed part is not important, the sheet with a hole is important, and sometimes the sheet with a hole is not important, the removed part is important. For example, gun barrel. Gun barrel आपने देखा है कैसा होता है gun barrel? Have you seen gun barrel? It looks like this, and if you actually check back from the vertical end, it goes like this. You are having, it is perforated. You are having holes. You are having holes here. Is it clear? This is your gun barrel. So now a sheet is taken, multiple hole is drawn, and that sheet is rolled. And again the sheet is rolled. And again the sheet is rolled. इसके बाद फिर से हमने शीट को रोल डाउन कर दिया था. ठीक है, जब शीट को रोल कर लिया तो डोंट यू थिंक हमारा गन बैरल बन जाएगा? यस. सो दैट इज व्हाई ऐसा नहीं है सर ब्लैंकिंग इज इंपॉर्टेंट. समटाइम्स बोथ ब्लैंकिंग एंड पंचिंग इज इंपॉर्टेंट. ठीक है. चलो ठीक है. दिस इज इंपॉर्टेंट. आई होप यू हैव नोटेड इट डाउन. आई होप यू हैव नोटेड इट डाउन. ठीक है, लिखो. द होल एंड द मेटल लेफ्ट बिहाइंड is discarded in case of the hole and the metal left behind is discarded in case of blanking operation. 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 Whereas the removed part The removed part is discarded in case of punching operation. The removed part is discarded in case of punching operation. Discarded, whereas the removed part is discarded in case of punching operation. Is discarded in case of punching operation. ठीक है, बिल्कुल सही है भाई, कोई दिक्कत नहीं है. ठीक है, इसके बाद we'll come to this again, don't worry, we'll come to this again. Give the third heading notching is important. Definition पता होनी चाहिए आपको. Notching लिखो. This is a cutting operation. This is not a metal forming operation. But since it is performed on a sheet, I am telling you, ये metal forming operation नहीं है, forming नहीं है. This is cutting, but minute cutting. Sheet metal में कैसा होता है? तो लिखो notching. Notching is defined as it is the cutting operation. Cutting, C-U-T-T-I-N-G. It is the cutting operation by which metal pieces are cut from the edges of the sheet. It is the cutting operation by which metal pieces are cut from the edges of the sheet. Metal pieces are cut from the edges of the sheet और द ब्लैंक. अब हो सकता है ना, देखो इस शीट के यहां से थोड़ा सा पार्ट रिमूव कर दिया और सपोज यू हैव रिमूव्ड अ ब्लैंक, यहां से थोड़ा सा एक पार्ट रिमूव कर दिया. सो देयर आर मल्टीपल थिंग. फॉर एग्जांपल यहां से एक छोटा सा पार्ट रिमूव कर दिया. इज इट क्लियर टू ऑल ऑफ यू? इज इट क्लियर टू ऑल ऑफ यू? छोटे छोटे पार्ट्स रिमूव कर दिए. सो दैट इज नॉचिंग. दैट इज व्हाट इज कॉल्ड एज नॉचिंग. ठीक है, इसके बाद लिखो परफोरेटिंग. परफोरेटिंग, 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 परफोरेटिंग. तो लिखो दिस इज अ प्रोसेस बाय विच, this is a process by which, this is a process by which multiple holes which are very small, this is the process by which multiple holes which are very small and close are together cut into the workpiece, are together cut into the workpiece, are together cut into the workpiece. ठीक है, बहुत सारे होल्स अगर एक बार में कर रहे हैं, सो मोर देन पंचिंग, दिस इज एन एग्जांपल ऑफ परफोरेटिंग. ठीक है, याद रखना, मोर देन पंचिंग इट इज परफोरेटिंग. Just a second. चलो लिखो, इसके बाद लिखो ट्रिमिंग. कुछ इंपॉर्टेंट पार्ट्स रहते हैं. ट्रिमिंग, ट्रिमिंग इज नथिंग बट रिमूविंग द एक्सेस मटेरियल फ्रॉम द बाउंड्री. ठीक है. फोर्थ, फिफ्थ लिखो शेविंग. शेविंग इज इंपॉर्टेंट. शेविंग लिखो the edges of the blanked part, 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 the edges of the blanked part are generally rough, uneven and are rough, uneven and out of dimension. and out of dimension, and out of dimension. Accurate dimensions of the part, ध्यान से सुनना, accurate dimensions of the part are obtained by active accurate dimensions of the part are obtained by removing a thin strip of metal, removing a thin strip of metal along the edges, along the edges. आप एक पूरी लेयर मेटल की रिमूव कर देते हो, बहुत थिन सी, सो पूरा सरफेस जो है वो फाइन टाइप का हो जाता है. Is it clear? The edges of the blank part are generally rough, uneven and out of dimension. Accurate dimension of the parts are obtained by removing a thin strip of metal along the edges. This operation is known as shaving. This operation is known as shaving. ठीक है. इसके बाद एक लिखो स्लिटिंग. स्लिटिंग इज इंपॉर्टेंट. स्लिटिंग बहुत लोग समझते नहीं है. स्लिटिंग इज, लिखो, इट रिफर्स टू द ऑपरेशन ऑफ मेकिंग, इट रिफर्स टू द ऑपरेशन ऑफ मेकिंग. हेलो एवरीवन इन द चैट सेक्शन, हेलो एवरीवन इन द चैट सेक्शन, प्लीज नोट इट डाउन. स्लिटिंग, स्लिटिंग क्या होता है? देखो, पूरा होल अगर मैंने निकाल दिया, दैट इज पंचिंग और ब्लैंकिंग. बट इफ आई एम कटिंग हाफ होल, इफ आई एम कटिंग हाफ होल, then what? If I am cutting half hole, then what? तो लिखो, it refers to the operation of making incomplete holes in the workpiece. It refers to the operation of making incomplete holes in the workpiece. It refers to the operation of making incomplete holes in the workpiece. Incomplete holes in the workpiece. Incomplete holes in the workpiece. For your information guys, today I have kept a session, that is the practice session from 8 p.m. on sheet metal operation only. ठीक है, every day at 7-8 p.m. we are going to have the lectures. You don't worry about that. ठीक है, you don't worry about that. हाँ, आज के लिए मैंने क्वेश्चंस का लेक्चर ऑलरेडी लॉन्च कर दिया है. प्लीज शेयर इट इन ऑल द ग्रुप्स टू ऑल द पीपल आउट देयर इन योर कॉल. मतलब जितने भी ग्रुप्स है ना, प्लीज शेयर अप कर दो, बिकॉज दैट मोटिवेट्स मी टू मेक मोर सेशंस. ठीक है, आई हैव ऑलरेडी लॉन्च द सेशन. यू कैन गो टू माय प्रोफाइल एंड यू विल गेट टू नो अबाउट लेक्चर नंबर 13 ऑन शीट मेटल ऑपरेशन, दैट इज मैन्युफैक्चरिंग प्रैक्टिस सेट. लेक्चर नंबर 13 शीट मेटल ऑपरेशन, लेक्चर नंबर 14 शीट मेटल ऑपरेशन. इज इट क्लियर टू ऑल ऑफ यू? Is it clear to all of you? Please share it as much as you can from 8 p.m. today. That lecture is there. I want maximum strength in that lecture and I want you to answer question in that particular lecture. Answering question on Unacademy free special classes. जैसा पहले से चलता आ रहा है वैसा ही है. ठीक है, lecture 12 lectures में already ले चुका हूँ. So that is why this is lecture number 13-14 and if it permits 15. ठीक है, ऑन अनअकैडमी फ्री स्पेशल क्लासेस. यू डोंट हैव टू पे एनी चार्ज. लिखो, लिखो. इसके बाद लिखो लैंसिंग. एक काम करो, ये लिख लो निबलिंग. सबसे इंपॉर्टेंट, ये आया भी हुआ है, निबलिंग. निबलिंग. गिव द हेडिंग एंड राइट निबलिंग. It is used for small quantities of component. It is used for small quantities of component and basically it cuts flat part from the sheet metal. Basically it cuts flat part from the sheet metal. Basically it cuts flat part from the sheet metal. Basically it cuts flat part from the sheet metal. Flat part from the sheet metal it cuts. ठीक है, चलो आगे लिखो. The flat part सबसे इंपॉर्टेंट पार्ट है. Now the blank is of cylindrical shape. The lancing, notching, perforating, everything is defined shape. Nibbling, you can actually create any shape. You can actually create any shape. Suppose this is your workpiece. Now you can take a nibbling operation like this also. Is it clear? This is your nibbling operation. That is, you can make any desired contour. You can make any desired contour. You can make any desired contour. तो लिखो, the flat part ranges from the flat part ranges from the flat part ranges from simple to complex contour. Simplex to complex contour. Simplex to complex contour. This operation is generally substituted for blanking. This operation is generally substituted for blanking. अब देखो, मुझे straight blank नहीं चाहिए, मुझे टेढ़ा मेढ़ा blank चाहिए. Is it clear? So you are having a ball that is having you can say thorns on it. So when it goes into the workpiece, we can guide the ball how it is going to flow through the workpiece, and as soon as it flows to a particular part, it eliminates that part and create a hole. Is it clear? That is what nibbling it. Nibbling में random contour का use हो जाता है. We can make random contours. We can make random contours. Random contours. Is it clear? चलो अगला लिखो, bending. B-E-N-D-I-N-G. Bending. अगला लिखो bending. In this operation, the material is in form of flat sheet or strip. In this operation, the material is form of flat sheet or strip, and it is uniformly strained around a linear axis, and it is usually uniformly strained around a linear axis which lies in the neutral plane and perpendicular to the lengthwise direction of the sheet. And perpendicular to the lengthwise direction of the sheet. तो देखो बेंडिंग लिख लिया आपने, GH, and finally last is drawing, deep drawing. लास्ट वाला है ड्राइंग. एक बार ये पूरा हो गया, देन अगेन वी विल स्टार्ट फ्रॉम पंचिंग एंड ब्लैंकिंग, एंड नाउ यू नो all the sheet metal operation that you need to study. The only two important sheet metal operation that I have not considered is coining and embossing. ठीक है, वो मैं कवर अप करा दूंगा, डोंट वरी अबाउट दैट. लिखो, the process of forming a flat workpiece, the process of forming a flat workpiece into the hollow shape, by means of hollow shape by means of punch, by the means of punch, which causes the blank to flow into the die cavity, which causes the blank to flow into the die cavity. ठीक है, तो ये सारे ऑपरेशंस हो गए. नाउ लेट अस स्टार्ट विद द पंचिंग एंड ब्लैंकिंग कोर पार्ट. पंचिंग एंड ब्लैंकिंग कोर पार्ट. ठीक है, देखो, the ultimate thing is that we should know how much force and how much pressure we need to apply. How much force and how much pressure we need to apply, that's all we need to do. ठीक है, तो give the heading. पहले ये हेडिंग दो, मेथड ऑफ ऑपरेशन. मेथड ऑफ ऑपरेशन. तो देखो कौन से डाइज हैं जो इसमें यूज हो सकते हैं. द फर्स्ट वन इज द सिंपल डाई. द सेकेंड वन इज योर कंपाउंड डाई. And the third one is combination dies. ठीक है, these are the dice that we need to explain, these are the dice that you need to understand, that's it. तो सबसे पहले लिखो simple die, give the heading simple die and start noting down. They are used for single operation. They are used for simple operation just a second, I'll be back from washroom, just a second. मैंने कल भी आपको बताया था मैं काफी पानी पीता हूँ तो चलो ये वो लेकिन मैंने पॉज किया था इतना आसान कर दो जस्ट अ सेकंड ओके सो वी आर कंटिन्यूइंग सो अब हेडिंग दो सिंपल डाई देखो सिंपल डाई क्या होता है your sheet will come like this. This is your sheet. This is your sheet. Now, a die will come down. A die will come down, remove this area, this material, and it will be collected as a blank downwards. As a blank. बिल्कुल सही है सर, बिल्कुल सही है, कोई दिक्कत नहीं है. This is your simple die. This is your simple die. Sir, what is compound die then? तो देखो, you are having a die like this, and there is one more die that is operating inside it. I hope you are trying to imagine कि कैसा होगा ये. ठीक है. So whenever this die will come down, this die will also come down. So ध्यान से देखना क्या होगा. This blue part, the bigger blue die will remove this material, and this die will remove this material. So ultimately your blank is removed due to the outer die, and due to the inner punch a small amount of material is removed from here. So it is like a washer. Example इसका best होता है washer. That is, I am eliminating a material, and along with that I am eliminating the material that is in between also. So this is nothing but a hole. So due to the second punch, in one shot only, देखो अदरवाइज क्या कर सकते थे, पहले ब्लैंक बनाया, फिर ब्लैंक के अंदर हम सर्कुलर होल कर दे. But in this case, there is a punch inside a punch, and that is why the outer punch cuts up the circular part, and the inner punch is cutting the inner circular part. So leading to the formation of a washer-shaped material. Is it clear to all of you? Leading to the formation of washer-shaped material. Such dies are known as compound die. Such die is known as compound die. Such dies are known as compound dies. Such dies are known as compound dies. तो लिखो, simple die में लिखो, single die or single action dies perform single operation for each stroke of the press slide. For each stroke of the press slide, one operation is performed. Compound die में लिखो. In compound die, please note down. In this, two or more operations may be performed at one station. देखो यहाँ पे दो ऑपरेशन हो रहे हैं. Cutting the outer part is blanking. Cutting and removing the inner hole is punching. Yes or no? So both two or more operations are being performed at the same workstation. At the same workstation. Is it clear? At the same workstation. लिखो. Such cutting operations are carried out. ये ऐसा लिखो. For example, washer is made in one stroke. Washer is made in one stroke, performing two operations. After performing two operations, that is blanking and punching both. इसके बाद लिखो कॉम्बिनेशन डाई. और ये थोड़ा इंपॉर्टेंट है समझना. It is a die in which one operation और ऐसा लिखो more than one operation will be performed at one station, will be performed at one station. But it differs from the compound die in such a manner, it differs from the compound die in such a manner very soon. Abhishek Kumar, very soon I'll be taking a class on plus, don't worry. Today I am having a special class. If you want, you can join me in that. From 8 p.m. today we are having the practice session of manufacturing. लिखो combination में लिखो it differs from the compound die by the fact, देखो कॉम्बिनेशन डाई में क्या होता है, एक साथ दो तीन ऑपरेशंस होते हैं, ठीक है. फॉर एग्जाम्पल अ सिंगल पंचिंग इज बीइंग परफॉर्म्ड एट द सेम टाइम, a compound punching, 3-layer compound punching is being performed. Three-layer compound punching is performed. Again, one you can say a single cutting is performed. Is it clear? So now this is not a compound operation. It is a combination of simple die and compound die. That's why it is known as combination die. It is a combination of simple die and compound die. It is the combination of simple die and compound die. ठीक है. इसके बाद लिखो फोर्थ, लिखो प्रोग्रेसिव डाइज. प्रोग्रेसिव डाई, प्रोग्रेसिव डाई. प्रोग्रेसिव डाई में क्या होता है, ध्यान से समझो. सबसे पहले क्या होगा, एक ऑपरेशन होगा, फिर आगे बढ़ेगा, फिर दूसरा ऑपरेशन. सपोज यू कैन टेक एन एग्जांपल ऑफ मोटर व्हीकल, हाउ द मैन्युफैक्चरिंग ऑफ ऑटोमोबाइल सेक्टर टेक्स प्लेस. Operation is done, then it goes forward, another operation is done, then it goes forward, another operation is done. Similarly the progressive die is there, 1 2 3 4. ठीक है. So that is why suppose you need to make this part, suppose you need to make this part. Suppose this shape you need to make. Suppose this shape you need to make. Suppose you need to make this shape, then what happens? Suppose you need to make this shape, then what happens? इसके बाद क्या होगा, देखो अब कई एक साथ में सारी चीजें नहीं कर रहा हूं. इन दिस ऑपरेशन all the punch will come down together. क्या होगा, all the punch will come down together, all the punches will come down together. Whereas in progressive die, one by one they will come down, one by one they will come down. ठीक है, one by one they will come down. ठीक है, चलो. So this is all about many methods of operation. अब देखो ये क्रैश कोर्स है, मैं बहुत ज्यादा डिटेल में तो नहीं घुस सकता हूं, बट यस आई वांट टू कवर ईच एंड एवरीथिंग सो दैट यू शुड नॉट फील कि कुछ छूट गया है. ठीक है, अब देखो प्रिंसिपल ऑफ कटिंग, principle of sheet metal operation. प्रिंसिपल ऑफ शीट मेटल ऑपरेशन. ठीक है, तो देखो होता क्या है, बहुत ध्यान से समझना. मैं डायग्राम बना के आपको समझा रहा हूं. दिस इज वेरी वेरी इंपॉर्टेंट गाइस. देखो दिस इज योर पंच. देखो अच्छा पंच बनाएंगे. दिस इज योर पंच. This is your punch and This is your sheet. ठीक है, this is your sheet. When this punch will come down, this is, I will be explaining this only once. ठीक है, बाकी processes के लिए मैं repeat नहीं करूंगा. When the punch will come down, this part will try to get removed. It forms a shape like this. When the force is applied, it forms a shape like this. Is it clear? ये जो बीच वाला पार्ट है इसका शेप कुछ इस तरीके का हो जाता है. आफ्टर दैट इट गेट डिअटैच्ड फ्रॉम दीज पार्ट्स एंड अ सर्कुलर पार्ट इज ऑब्टेन्ड. ठीक है, कोई दिक्कत नहीं है. बट व्हेन इट इज एट दिस पार्ट, it is applying the compressive load. Yes or no? This is your punch. This is your sheet. And here are your dies. These are your dies. These are your dies. ये जो ब्लू कलर के हैं ये आपके डाई हैं. As soon as you will apply the force using this punch, as soon as you will apply the force using this punch, it applies the compressive stress. It applies the compressive stress from the top. And if you see, this part will be facing a tensile stress. So the top face is facing the compressive load. And the bottom face is facing tensile load. Is it clear? So there, layer by layer, there is a difference. The top layer is feeling the compressive load. The lower layer is feeling the tensile load. The lower layer is feeling the tensile load. The lower layer is feeling the tensile load. Is it clear to all of you? And that is why we say in punching and blanking operation, both compressive and tensile stress is generated. Stress is generated. Is it clear? ऊपर वाली लेयर में compressive load है, no doubt, but the lower layer is trying to go away from the remaining material. So that is, don't you think there will be a stretch at the lower level? Don't you think there will be stretch at the lower level? Obviously there will be stretch at the lower level. Why? Because the lower level is trying to go down, the remaining material is not going down. Automatically the cut will be there. Automatically the cutting will take place. The cut will be there, but the die is applying compressive load on the sheet, and the upper layer of the sheet and the lower layer of sheet is feeling tensile forces. This is very important guys, याद रखना. ठीक है, अब ये चीज नोट डाउन कर लो, ये डायग्राम बना लो सबसे पहले. दिस इज वेरी इंपॉर्टेंट. दिस इज लिटरली वेरी इंपॉर्टेंट. फटाफट नोट डाउन करो. आई एम गिविंग यू अ मिनट, प्लीज नोट इट डाउन. इंपॉर्टेंट है ये, काफी इंपॉर्टेंट है, रादर काफी इंपॉर्टेंट है ये. बस जो गेट में पूछा जाएगा ना वो यही पूछा जाता है. That is what are the different forces or the stresses generated in punching, blanking, bending, deep drawing, and if you know this thing, you will be comfortable with it. You will be absolutely comfortable with it. लिखो, अगला लिखो. इसके बाद हेडिंग दो. प्रिंसिपल समझ में आ गया, कंप्रेसिव टेंसाइल लोड. सो क्रैकिंग इनिशिएट्स फ्रॉम दिस एंड एंड अल्टीमेटली अ क्रैक्ड वर्कपीस is dropped, and this is your remaining part. This is your cut. This is your removed part. This is your removed part. This is your removed part. ठीक है, अब लिखो अगली हेडिंग दो, क्लियरेंस। सर क्लियरेंस का क्या फंडा रहता है, तो देखो पंचिंग एंड ब्लैंकिंग में क्लियरेंस का क्या फंडा रहता है। देखो ऑब्वियसली सपोज this is your sheet. I'm making the small diagram only so that quickly I can wrap up also. Suppose this is your sheet and this is your punch. The red color one is your punch and blue color ones are your die. This is your die. ये कुछ नहीं है फालतू की चीज। This is your die. When the punch will try to come down, don't you think the wall of the punch and the wall of the die will rub against each other? Don't you think the wall of the punch and the wall of the die will rub against each other? So that is why लिखो that is लिखो the size of the punch and die are interrelated. The size of the punch and the die are interrelated. The size of the punch and the die are interrelated. The size of the punch and die are interrelated. Are interrelated. The size of the punch and the die are interrelated. Interrelated in such a manner that diameter of die is always bigger than diameter of punch. Diameter of die is always greater than the diameter of the punch. Is always greater than the diameter of the punch. Diameter of the die is more than the diameter of the punch. More than the diameter of the punch, and the relationship is given by diameter of the die is equal to diameter of the punch plus 2 clearance, where C is given by, ध्यान से देखना, 0.0032 into T into root over tau, where T is the thickness of sheet, tau is your shear strength of material, and C is nothing but radial clearance. ठीक है, what is 2C? 2C is diametrical clearance. So if radial clearance is given, then diameter of the die is equal to diameter of the punch plus 2 times the diametrical clearance. तो अगर क्वेश्चन में diametrical clearance दिखाए, you don't have to multiply it with 2. Very important, स्टार मार्क करके ये लिख लीजिए. If diametrical clearance is given in the question, you don't have to multiply it with 2. And if radial clearance is given, then you can multiply it with 2 to get the value of diametrical clearance. Please note it down. This is important. The strength of the material will be given in Newton per mm square. Sheet of the metal will be given in mm. The clearance will be, we will be giving the output in mm. देखो, अब क्लियरेंस काय पे होती है, दैट इज वेरी वेरी इंपॉर्टेंट। ठीक है, क्लियरेंस काय पे होती है, ये बहुत ज्यादा इंपॉर्टेंट है, बहुत ही ज्यादा इंपॉर्टेंट है। तो यहां लिखो पंच कंट्रोल होल साइज एंड डाई कंट्रोल ब्लैंक साइज। तो देखो, ध्यान से समझना, if the operation is blanking operation, if the operation is blanking operation, then blank is important for me, yes or no? So diameter of the blank will be equal to diameter of die, yes or no? Because diameter of the die is one which is controlling the blank size, तो मेरा blank size fixed है, that is blank size is equal to diameter of die. Always remember that blank size is equal to diameter of die, and diameter of punch is equal to diameter of die minus 2 times clearance. ठीक है, simple. Now in case of punching operation, hole is important, क्योंकि punching operation is one in which you are having a sheet with a hole, so size of the hole should be accurate. So whatever is the size of the hole, that will be equal to the size of the punch, because my punch controls the whole size, my punch controls the whole size, yes or no? Yes, punch का जो भी size होगा वही hole का size होगा. So suppose I want my 20 mm hole, then don't you think the punch should also be used for 20 mm hole? Obviously yes. So diameter of the die will be equal to diameter of the punch plus 2 times clearance. Is it clear? So this is how you get the value of diameter of die and diameter of punch. This is very very important, diameter of die and diameter of punch. Is it clear to all of you? ठीक है, क्लियरेंस बहुत ज्यादा जरूरी है, बहुत ही ज्यादा जरूरी है। ठीक है, तो अब ये इंपॉर्टेंट काम था कि क्या आप साइज लोगे। सपोज आई वांट टू मेक let us say this charger. So suppose I want to make a charger with a defined hole in between. अब होल का साइज मैंने 20 mm diameter दे दिया, तो don't you think my punch should be of 20 mm diameter which is creating this hole, because hole का size will be dependent on punch का size. Whatever is the removed material, what is the size of the removed material, that I am not concerned with, that I am literally not concerned with. I am only concerned with what? I'm only concerned with what? I am concerned with the whole part. Hole is dependent on the punch shape, punch size. Hole is dependent on the punch shape and size. Is it clear to all of you? So that is why आपको ये चीज समझ में आनी चाहिए. That is why you should understand that whenever punching operation is there, whenever like piercing, punching, perforating, जहां पर भी होल की बात हो रही है, we will say the size of the hole is equal to size of the punch and diameter of the die will be somewhat higher. Whereas whenever the blanking operation is there, diameter of the die is equal to the diameter of the blank, and whatever is the size of the punch, that will be a bit smaller than the diameter of the die. Is it clear to all of you? अब लिखो कटिंग फोर्सेस, उसके लिए चार्जर लगा देते हैं 2 मिनट. Now ultimately, being a production engineer, you should know what are the forces engaged in it. You should know what are the forces engaged in it. You should know what are the forces engaged in it. So देखो, just a second, I'll connect the charger. मुश्किल आसान कर दो। चलो वील कंटिन्यू। तो देखो सबसे पहली बात तो यहां पे ध्यान रखो कि हुआ क्या। द साइज ऑफ द डायमीटर ऑफ द ब्लैंक इज इक्वल टू डायमीटर ऑफ द डाई, सो दैट इज वाई क्लियरेंस इज प्रोवाइडेड ऑन द पंच। पंच को मैंने थोड़ा छोटा बना दिया। क्लियरेंस इज प्रोवाइडेड ऑन पंच, whereas in this case clearance is provided on die, on die. The clearance is provided on die. Is it clear? This is very very important for you to understand कि clearance क्यों दे रहे हैं हम एक दूसरे को. Why the clearance is given to the punch in blanking operation and why the clearance to the die is given in the punching operation. ये चीज पता होनी चाहिए. Calculation is in front of you. अब बात आती है cutting force की. तो देखो लिखो, पहले ये लिख लो, काम की चीज है, थोड़ा थ्योरी करके फिर आगे बढ़ते हैं। और शेयर का कॉन्सेप्ट आएगा इसके बाद, विच इज वेरी वेरी इंपॉर्टेंट। जो मोस्टली क्वेश्चंस आए हैं ना वो शेयर से ही आए हैं। तो लिखो लिखो इन कटिंग ऑपरेशन, इन कटिंग ऑपरेशन, इन कटिंग ऑपरेशन, आवाज आ रही है कि नहीं बढ़िया? चलो ये चेक कर लेंगे। अभी आप लिखो इन द कटिंग ऑपरेशन एज द पंच इन द डाउनवर्ड मूवमेंट एंटर्स द मटेरियल। ध्यान से सुनना, ये बहुत ज्यादा जरूरी चीज है। अगर आपको ये चीज समझ में आ गई सो कटिंग फोर्स में कोई भी दिक्कत नहीं होगी। एंड स्पेसिफिकली इट विल आल्सो हेल्प यू टू अंडरस्टैंड द कॉन्सेप्ट ऑफ shear force. What is not shear force, shear? What is the concept of applying shear? Is it clear to you? लिखो चलो सब सही चल रहा है। अब देखो ध्यान से देखो, लिखो in cutting operation as the punch is moving in the downward direction and enter the material, the punch is moving in the downward direction and enter the material, it need not को अंडरलाइन करिएगा, it need not penetrate the thickness of the stalk, penetrate the thickness of the stalk in order to effect कंप्लीट रप्चर ऑफ द पार्ट। अगर आपको प्रॉपर कटिंग करनी है, जरूरी नहीं कि आप पूरा पंच नीचे तक लेके जाएंगे। इफ द पंच इज हाफ वे डाउन, इट माइट बी पॉसिबल दैट क्रैक इज इनिशिएटेड एंड ऑटोमेटिकली द ब्लैंक इज रिमूव्ड ओनली आफ्टर एंटरिंग half the way, half the thickness. Suppose आपकी ये thickness है, suppose your thickness is like this. Now the punch will go to this depth, the punch will go to this depth and automatically the part will be removed, and automatically the part will be removed. Do you know why? It is not necessary that punch is going till complete thickness of the workpiece. That is what the कवि यहाँ पे कहना चाह रहे हैं। ठीक है, कविवर जो यहाँ कहना चाह रहे हैं वो यही है। देखो, it need not penetrate the thickness of the stalk in order to affect complete rupture of the part. In order to affect complete rupture of the part. In order to affect complete rupture of the part. ठीक है। कंप्लीट रप्चर ऑफ द पार्ट, the distance up to which, देखो full stop, the distance up to which the punch enter into the work material, the distance up to which the punch enter into the work material, the punch enter into the work material, tau is the property of the material, it comes from experiment, it does not comes from formula, ठीक है। tau is the property of material, tau is the shear strength of the material, depending on different material the value is different, तो आप कोई फॉर्मूला लगा के tau की वैल्यू नहीं निकाल सकते हैं। from tau various other values can be find out, देखो, the distance which the punch enters into the work material to cause rupture is known as penetration and is usually represented by percentage of thickness, and it is usually represented by percentage of thickness, it is usually represented by percentage of thickness, it is usually represented by percentage of thickness। लिखो, लिखो, द परसेंटेज पेनिट्रेशन, अब ये पेनिट्रेशन कितना होगा, तो लिखो द परसेंटेज पेनिट्रेशन, द परसेंटेज पेनिट्रेशन the percentage penetration depend on the material being cut, depend on the material being cut, depend on the material being cut, and also on the stock thickness, and also on the stock thickness, and also on the stock thickness। देखो, when hard, ये इंपॉर्टेंट लाइन है, बहुत सारे लोग बहुत बड़ी गलती करते हैं। when hard and strong material is being machined, or like when we are performing the operation on hard and strong material, that is the sheet is made up of hard and strong material, will you require low penetration or a high penetration, तो लिखो whenever the thickness of the whenever a hard and strong material is being cut, whenever hard and strong material is being cut, very little penetration of the punch is necessary। आपको लगेगा कि भाई बड़ा है, ज्यादा हार्ड है, तो ज्यादा डेप्थ में पेनिट्रेशन, नो, ब्रिटल स्ट्रक्चर में बहुत कम पेनिट्रेशन चाहिए रहता है, ब्रिटल स्ट्रक्चर में बहुत कम पेनिट्रेशन चाहिए रहता है। इज इट क्लियर टू ऑल ऑफ यू, तो लिखो very little penetration of the punch is necessary to cause fracture, very little penetration of the punch is necessary to cause fracture। with the increase in the ductility the penetration value increases, ये स्टार मार्क करके लिख लेना, with the increase in देखो With the increase in the ductility of the material, the penetration value will increase. अब देखो फोर्स होता क्या है, ये सब चीजें तो देख ली. अब देखो फोर्स इज इक्वल टू स्ट्रेस इनटू एरिया. स्ट्रेस इनटू एरिया, बिल्कुल सही है. व्हाट इज द वैल्यू ऑफ स्ट्रेस? टाउ. व्हाट इज द वैल्यू ऑफ एरिया? देखो whenever the blanking is being performed on the side walls, the curved surface area of the blank, on the curved surface area of the blank, the force is applied. So the value is pi diameter of the blank into the thickness. Diameter of the blank into the thickness. Pi dt. Pi dt. Pi dt. Is it clear to all of you? Now what is pi d? Many will call it as perimeter. तो याद रखना, sometimes this is also the formula, perimeter of blank into tau into t. ठीक है, into tau into t. Is it clear to all of you? ठीक है, this is your force. अब force में here thickness will come, punch travel or the penetration will not come. This is thickness. This is thickness. But if somebody asks you what is the power or what is the energy, then energy is given by force into displacement. Work done is force into displacement. Force into displacement. Force into displacement. What is the force? Force is tau into pi dt into what is the displacement? Small p. Small p is the penetration. Because penetration, punch travel, force into what is the distance traveled, which is that is equal to the punch travel. Punch ने कितना travel किया, that is equal to penetration. Yes or no? That is equal to penetration. That is equal to penetration. So if you ask what is the energy? What is the energy? The energy, this is the maximum force. This is also known as F max. This is F max. This is F max. बहुत अच्छा कॉन्सेप्ट पता चल जाएगा, अभी आप ध्यान देते रहो तो. This is F max. This is F max. ध्यान से देखो, अगर ये F max है, if this is F max into force into displacement, this is your energy. This is your energy. Now this is the total value of energy, power, work done, जो भी आप कहना चाहो. But now what happens in any industry? Task is defined based on कैपेसिटी ऑफ देयर मशीन. ऑब्वियसली जितनी आपकी मशीन की कैपेसिटी होगी उसी के हिसाब से तो आप अपना फोर्स डिसाइड करोगे. उसी के हिसाब से तो आप अपना फोर्स डिसाइड करोगे. यस और नो? कैपेसिटी ऑफ मशीन. ठीक है. हाउ द कैपेसिटी ऑफ मशीन इज डिसाइडेड? बेस्ड ऑन मैक्सिमम फोर्स इट कैन अप्लाई. ध्यान से देखो, अब अगर मुझे सपोज एफ मैक्स का वैल्यू आ रहा है 500 किलो न्यूटन. नाउ इफ आई एम हैविंग द मशीन ऑफ 499 किलो न्यूटन, डू यू थिंक इट इज सफिशिएंट टू परफॉर्म द टास्क? नो, because I don't care whatever is my capacity, but if 500 kilonewton is required in one go, after 500 newton it will decrease, but at one point I require 500 kilonewton of force. If I cannot provide 500 kilonewton of force, I can provide 499 kilonewton of force, but the process cannot initiate, because to initiate this process is this is required. ये initiate ही नहीं कर सकता मैं. Is it clear? So that is why the machine is decided based on maximum force it can apply. Now suppose I am having a machine that can apply 400 kilonewton of maximum load at one go. ये मैंने define किया. मेरे पास जो machine है that can apply 499 kilonewton of force in one go. ठीक है. But now the force required is 500 or 600 kilonewton. Is my machine sufficient? No. My machine cannot initiate the process. My machine cannot even initiate the process. तो होता क्या है, ध्यान से देखो, बहुत ध्यान से देखना. यहां पे क्या होगा? I'll draw a graph. This is punch travel and this is load. So you will start applying the force as soon as it reaches the value of 500 kilonewton. Suppose this value is 500 kilonewton. Okay. As soon as it reaches 500 kilonewton, automatically the punch, now no more punch travel is required. The punch will stay there, automatically the crack initiates and the cutting is performed. The cutting is performed. Is it clear? Is it clear? So that is why this is the amount of punch travel. Let us say this is X and this is the value of F max. 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 This is the procedure that I am applying force. The punch is inserting, getting inserted, and as soon as that maximum value is reached, automatically the crack initiates and the task is done. I don't require further punch travel. Okay. But sometimes the reaching up to, if I am not reaching up to this force 500 kilonewton, do you think that I will be able to perform the task? No. I don't even require 500 kilonewton throughout the process. I just require the maximum one point at one go. In one go, I can apply 500 kilonewton. That is all I want. That is all I want. Is it clear? Is it clear? That is all I want. ठीक है, बस आपको यही करना है. So that is why if the machine is of 499 kilonewton, it cannot perform the task. That is the poorest thing. Then how to reduce this maximum load? Question is, if I can reduce this maximum load, don't you think that my task will be done with the given machine? Because now I will not go to the market and buy a new machine that can apply 500 kilonewton of force. Why will I do that for one operation? I want the same operation to be done in this machine, which can apply maximum load of 499. So that is why you need to reduce F max. How to reduce F max? How to reduce F max? This is the task for now. If I can reduce the F max, I can perform it with the limited amount of machines only. Okay. Is it clear? So now it's your job to find out how to reduce the force. How to reduce the force? What are the different methods with the help of which we can reduce the force? What are the different methods with the help of which we can reduce the force? So there are two ways. Staggering of punches. ये तो बहुत सिंपल सा मेथड है. Staggering of punch, and second, the most important, providing shear. So tomorrow we will start with providing shear and staggering of punches. Now from the gate perspective, this numerical from shear is very important. We will be starting from 2:30 in the morning and One more announcement is there. Today at 8 p.m. we are going to have practice session on sheet metal operation. Practice session on sheet metal operation. Is it clear? And at 9:10 p.m. we are going to have second session of practice session on sheet metal operation. This is lecture number 13 in the series and this will be lecture number 14. ठीक है. The earlier lecture have covered metal forming, welding, CAD CAM, बहुत सारी चीजें. But we will see. ठीक है. Sheet metal operation का आज दिन है. I hope you will be joining me on Unacademy. How you need to reach? Just type Unacademy Prakhar Srivastav in Google. You will go to my profile. In my profile, go to the special classes. Special class. In special class, you will see in the beginning only you can see the different classes that are live, and you can click on them and just, or rather you can just enroll in the class. In Telegram channel also I will post it. Not a very big deal. Okay, so you can obviously reach out to me. And what is my link? The link to my lectures is the link to all the free courses, paid courses, सब कुछ की link यही है. That is, this is my link of, or this is the profile of Unacademy. That is unacademy.com/Prakhar Srivastav 333. You can see a profile like this. You can see a profile like this. ठीक है. ये तो काफी पुराना डेटा है, but ठीक है. Still you can manage. And you can also follow our whole team on Unacademy ME Gate channel. Or that this is a Telegram channel where all the updates about all the different courses, videos, links to special classes, everything will be provided. And don't forget us to like on the Facebook page, that is creatric.mech is the name of the group that we are running right now. And the YouTube channels that we are having is Unacademy Gate MEPIXE. On this channel you are watching me right now. You can also go to Unacademy Gate Question and Unacademy SSC JEE. बहुत सारी चीजें, बहुत सारे channels available हैं. But depending on your preparation, you should select the channels that you want to convey. ठीक है. So I'm done for the day. I hope that you have enjoyed today's lecture. Metal forming introduction would have been a good thing for you. And don't forget to join me at 8 and 9 p.m. today in the special class. And we will continue with the crash course tomorrow 2:30 p.m. ठीक है. Thank you, all the best. Don't forget to subscribe to this channel. If you are having any doubt, please ask. If you have any doubt, you can ask. Otherwise, I'll wrap up the session.